Hey everybody, this is 4.3, solving by completing the square. Alright, so our last lesson, 4.2, is when we use square roots to solve. Alright, and what we're doing today is we are going to still kind of use that, but this is kind of part 2. So all of the problems that were given here is we already had just one variable and it's being squared, and that works really good when we're trying to solve using square roots. Okay, and then we use factoring whenever we could find the two things that multiply and add, but sometimes factoring doesn't work all the time. So these are the types of problems that we're going to be running into today. So these are not ready. These are not, let me say that again. You can't factor these. You can't find two things that multiply and add, at least without using like fractions and things like that, which isn't what we're going to work on because that just takes a lot more work. And then we can't use square roots to solve yet. But what we're going to do is we're going to complete the square. It's called complete the square. And then we'll be able to use square roots to solve. Okay, so buckle up because this is kind of a little doozy. But if you need to, pause, go back, listen again, come in and get help. Okay, so basically we're going to want to try and take equations that look like these and then so that they will look more like these. Okay. All right. So first off, we're talking about completing the square. So what do we know about squares? Maybe we should write a little thing over here. Is that they have the same length and width. So like if this is x, then this also has to be x. Or if this is x plus 2, this has got to be x plus 2. Okay? So that's what our goal is to make our equations make these nice perfect squares. Okay? So here's like a kind of like an opposite of what we're going to do is using the distributive property. Okay? If we were to evaluate this and kind of put it into standard form, is we would use the distributive property. Just remember that x plus 2 squared is the same as x plus 2 times itself. Okay, so we could have x and then we'd have 2 and we'd have x and 2. So again, this is a perfect square. Its length and its width are the same. The length is x plus 2 and its width is x plus 2. So if we were to multiply these, we would get x squared. So x squared is a perfect square in itself. And then we'd have 2x, and then 2x, and then 4. Again, if we were to like combine like terms, we'd get x squared plus 4x plus 4. Okay? Alright, so this one is kind of going backwards. This is kind of like when we did factoring using a box. We will factor out the greatest common factor for each row and column. So here we could factor out an x and a 3 and an x and a 3. And what do you know? This is a perfect square. It has the same length as its width. Okay, and we could write this as a binomial square. This would be x plus 3 times x plus 3, which is x plus 3 squared. All right, so then we'll also have some problems here. Let's see if you can pause and give this a try. See if you can figure out what that empty box needs to be. And it might be helpful to kind of go outward, like factor out the greatest common factor, or think about what the width and length it needs to be. Like for example, x times x has to give you x squared. Okay? Alright, so this would have to be 5 because 5 times x gives us 5x. And then 5 times 5 would give us 5x. Okay, so now we basically have that perfect square, but if we're trying to figure out what that missing spot is, we'd need to multiply those together to give us 25. Okay, now hold on tight. This is going to maybe start to, this will make sense in a little bit, okay? Alright, the last two, we can give that a try. So x times x is x squared. This would need to be negative 2, because negative 2 and x gives you negative 2x, and then the same thing here. And then to complete this square, this box would have to be a positive 4. Okay? Alright, so these problems, this is what I want you to do. I want you to what's called complete the square. I want you to figure out what these terms, these numbers need to be. Okay? It would be beneficial to kind of use what we did above. Again, we know that area, this is like, in standard form, this could be represented as an area. When we have binomials, that's like a length and a width. So area is, you know, the inside of a box, of a square. So this would have to be like x squared, right? And its length and width would have to be x times x. So that's a perfect square. Now we want to look at this 20x. We need this to stay like a square, so this length and width have to be the same. So when we look at this, like whenever we have like just a number and a variable, it's always these two terms. So like here, if we were to go this direction, we would need to split that middle term into two equal parts. This would need to be 10x and this would need to be 10x. That way, this would need to be 10 and this would need to be 10. That way it's a perfect square, right? It's x plus 10 times x plus 10. That's your length. This would be your width. The length and width are the same. Okay? So just remember, we always like cut it in half. Cut in half. Alright, and then to complete the square, 10 times 10 gives us 100. So this is what you're asked here to find, is what's the number that completes the square. Alright, why don't you give B a try if you can, pause, and do that. So again, it's a perfect square, so x squared is x times x. We need to do half of negative 18 on both sides. So negative 9x and negative 9x. So this would have to be negative 9 and negative 9. And then to complete the square, negative 9 times negative 9 would give us a positive 81. Okay? And then the last example, again, same sort of thing. X squared is a perfect square, x times x. Alright, next we do half of the middle term on both sides so that we can get x plus 3 and x plus 3. And then to complete the square, 3 times 3 is 9. Alright, so a perfect square trinomial can also be written as a binomial squared. Okay, and that's what we have here on the side, top and side. So this is the same as x plus 10 squared. So when we complete the square, we end up getting something that's a perfect square. This one is the same as x minus 9 squared. And this one would be x plus 3 squared. Okay, so we're almost there, guys. Alright, so these ones say convert each perfect square trinomial into a squared binomial. So basically it's the same thing over here, except we already completed the square. Maybe we'll do one of these. Alright, so we have x squared. Again, that's x times x. We have our middle term, cut it in half, so 3x and 3x. And then we know that this is 9. Okay, so if we factor out the greatest common factors, Here we just get x plus 3 squared. Okay. I don't know, these aren't too bad. Why don't we do these two? So we got x squared. Half of 12 is 6. And then we'd have 36. So we'd take out x's and negative 6's, and we'd get this is equal to x minus 6 squared. And then the last one we want to figure out what that is. Why don't you give that a try? But it should give you x minus 5 squared. All right, so now this is kind of like the culmination of all the stuff we've been talking about. These are problems that are not perfect squares, but we're going to complete the square, okay? So hold tight with me here. Okay, so here's same sort of thing. This is x squared. So we've got x and x. Half of this gives us 3. So we'll take half of it. Okay. And then here, what does this need to be? Well, this would need to be 9, but it needs to add to 10. So for these problems, we're going to make this extra box, and we need to figure out what we need to add to 9 to give you 10. So this would be plus 1. Okay, so here the box here is the binomial squared. That's our x plus 3 squared, and then we have what's left would be plus 1. So this is what we've been looking for. This looks like the types of problems we've had above. The only thing is that we'll end up having equations where they'll be equal to 0, and we'll get to that. So here's a couple of other examples. Pause and give it a try if you would, please. I promise you'll learn it so much better. So here we've got our x squared. Half of 10 is 5. Okay, so this has to be x and x. To give you x squared, this would have to be negative 5. Okay, and again, we're just hanging on to that for a while. We want to complete the square first. So negative 5 times negative 5 would give us 25. But it needs to give us 20. So what do we need to add to or subtract to give you 20? Well, we'd need to subtract 5, because 25 minus 5 gives you 20. Okay? Because we can't just like nilly-willy like change it. We have to still keep everything balanced or keep the same. Alright, so here we have our binomial squared, so x minus 5 squared, and then we're going to subtract 5 from it so that we haven't changed anything to the expression. And then that's it. Alright, next one, again, x squared plus half of 4 is 2, and then this would have to be x and x, and this would be 2 and 2. Again, 2 times 2 is 4, but we don't want 4. We want it to be equal to 7. So what do we need to do to 4 to give us 7? We need to add 3. So we'd have x plus 2 times x plus 2 gives you x plus 2 squared plus 3. Alright, so that is completing the square. Now, everything from now on is going to complete the square and then solve. So you've got this. Looks like we've got maybe 4 examples. I think that's all you would need. Again, you've done all the other stuff before. If you want extra practice, you could do A, B, and C here at the top of the screen. Just set them equal to 0 and then solve for x. Alright, so first off, we need to complete the square. You're going to need to draw your own boxes. Again, everything needs to be on one side. So everything on one side and then equal to 0. Okay, so we have everything on one side here. So we've got x squared is a perfect square. That's our x times x. Half of 6 is 3. And then that would have to be 3 and 3. And that gives us our binomial squared. And then we have to complete the square, so that gives us 9, but we don't want 9, we want it to be equal to -4. So we would need to, what would we need to do? We need to subtract, I think, 13. Okay? If it's helpful, really all we need to do is we'll take whatever's this minus whatever that is. So we just need to subtract 9 from it, so that gives us the -13. Okay, so now we can write down our equation in after completing the square. So this gives us x plus 3 square, that's our length and width multiplied. And then minus 13 is equal to, and again, this is equal to 0. Okay, and then we just need to solve. So again, it's like PEMDAS backwards. We'd add or subtract first. So this is -13, so we'll add 13. So x plus 3 squared equals 13. Alright, next we would do multiplication division, but there's none. So next would be exponents. So we would square root both sides. Don't forget the plus or minus. The square root of 13 cannot be simplified, so we'll just leave it. And then we would do what was inside the parenthesis. So that's the P for PEMDAS. So we'd subtract 3. So x is equal to -3 plus or minus square root of 13. And I would accept that, or you could write it twice. One would be the positive, and one would be the negative. Again, I'm okay either way. Alright, so that's basically it. So we'll do a few more examples together. Again, once you feel like you've got it, you don't need to finish watching this, but again, we'll complete the square. So x squared and half of 18 is 9. So that would factor out a 9. Here we factor out a 9. This would need to be -9 to make these work. And then to complete the square, it would have to be -9 times 9. Or -9 is what? 81. Okay. But we don't want 81. We want 21. So again, I think an easy way to do that is just subtract 81. Or I don't know, maybe we shouldn't write it there. Maybe just subtract 81. Okay, and I think that gives you -60. Right? Yeah. Okay, so now we can write down our equation. And then we'll just solve using square roots. So add, subtract first. Next in multiplication division, there isn't any, so we would subtract. And all of these are about the same, so really you just need a little bit of practice, and then it's hopefully going to all come to you pretty good. Don't forget the plus or minus. Don't forget simplifying your root. So we could do what? 2 and 30, 2 and 15, 3 and 5. So here we have a group. So plus or minus 2 square roots of what's not in a group. So that's 3 and 5. So that's 15. And then the last thing would be to do what was inside the parenthesis. So we'd subtract. So this would be our answer. X equals -9 plus or minus 2 square roots of 15. Alright, 2 more examples. So here, the first 2, everything was already on one side. Here we have like a constant on the right side for these both C and D. So these need to be moved over before we try and do anything. So we'd add 2. So that would give us 71. Okay. So let's do our box. Let's complete that square. X squared, half of 16 is 8. X and 8 and 8. Okay. And then what completes the square would be 8 times 8, which is 64. But we don't want 64, we want 71. Okay, so what would that box need to be? Again, we could subtract 64, and that ends up giving us 7. So 64 plus 7 is 71. So now I'll write down our equation, x plus 8 squared, equals, plus 7 is equal to 0. Again, if you wanted to, this would be a little daunting, or maybe take extra work that you don't need or want, you could distribute this back and then add that constant to it, and you should get the exact same thing that you started with. Okay, we'll actually get into that for our next unit when we need to switch forms, but hang on for that, that'll be fun. Okay, alright, so again, same sort of steps. We would subtract 7, we'd then square root. So this one's going to end up, oops, that should be squared. That will end up giving us an imaginary solution. So plus or minus I square roots of 7. And then we would subtract 8. So our solution would be negative 8 plus or minus I square roots of 7. Alright, last but not least, again, subtract 17. So what would that give you? Negative 11, right? And then we'll complete the square. So just for the heck of it, I'm just going to rewrite that so it's a little more clean. Pause and give this one a try if you haven't done that yet. So half of 10, oops, is 5, negative 5. What completes the square would be 25, but we don't want 25. We want it to equal negative 11. So again, we can just subtract 25, and that gives us what? Negative 36. So we get x minus 5 times x minus 5 is x minus 5 squared, minus 36 is equal to 0. So then we would add 36. We would square root both sides. Don't forget the plus or minus. And then we could add 5. Okay, so here these are both rational numbers, which means we can actually combine them together. 5 plus 6 equals 11, and 5 minus 6 gives us negative 1. So our answer would be 11, negative 1. Alright, so that's basically it. Sorry, this is probably a little longer video, but again, it's kind of tricky and takes a little bit of time, so I just wanted to give you lots of examples. Alright, so completing the square works great if a equals 1 and b equals even, or is even. And we've done all of these examples. You don't have to worry about it now. I just wanted to keep that in mind. So when we looked at all these examples, notice that all of the leading terms are a equals 1, and the middle term, b, is even. So there's 16, for this one it's 10, above that's 18, here it's 6. Okay, so that works really well. If it's not, then you'll probably want to try and use a different method. Okay. Alright, so just a reminder, move all the terms to the left. One side must be equal to 0. We then complete the square, that's what we added today. And then we use inverses to get x by itself. So that's what we did last time. We used square roots to solve. Okay, and we take off the layers of the onions as you go along these equations. Okay. All right. Well, let me know if you have any questions. Feel free to stop by. we'll see you later.